Hello guys, you are welcome to my channel once again. Remember in our previous lesson, we took a look at how to simplify sets. Today, we are going to take a look at how to add or subtract sets. That is addition and subtraction of sets. But before we move on to addition and subtraction of sets, that's the lesson that we have for today. Let's go back and then try to solve one example on simplifying sets or reducing sets to their basic forms. That is the lesson that we had in our previous episode. I gave you these examples to try your hands on. Let's take the first example and then try solving it to see whether you were able to have the same answer. I will leave the two for you. With square root of 128, let's take it. With this, remember we went through a particular process when we were simplifying sets. We said it is a perfect square multiplied by a prime number. So search for a perfect square multiplied by a prime number to give you 128. So with that, when you take 64 and you multiply it by 2, and you take 64, multiply it by 2, it will give you 128. 64 is a perfect square. When you find the square root of 64, you have 8. And then you can have the prime number, which will give you an irrational answer and then give you the set finally in your solution. So I go in for 64 multiplied by 2 because there's a perfect square and there's a prime number. So 128 is equal to 64 multiplied by 2. 64 multiplied by 2 will give you 128. Moving forward, find the square root of 64 and separately, and then find the square root of 2 separately. So square root of 64 will give us 8, then multiplied by square root of 2. 8 multiplies square root of 2, and then we have 8 root 2. So there's the final answer that we obtain after solving square root of 128. You take your calculator, you punch square root of 128. It gives you 8 root 2. Exactly the answer that we have over here. That is the exact answer that we have over here. The trick is to search for a perfect square and a prime number that will multiply to give you the product of the number. That is the number, the product. That is the number that you have in the square root. I believe you have followed. Let's box on and take a look at what we have for today. Addition and subtraction of sets. Welcome back once again. With the addition and then subtraction of sets, this is how we go about it. You can only add or subtract sets that are alike or have the same form. So with addition and subtraction of sets, when you have a set in this form, a square root of b plus c square root of b, then when you have a set in this form, then it means you can add or subtract one set from the other. Why? When you take a look at this particular square root, you have b in here. And when you take a look at this particular square root, you have another b in there. Before you can add one set to the other, make sure that the numbers, the values that are in or within the square roots are the same. So if here is b, here must be b before you can add this to that. Make sure the values in the square roots are the same. So if you have b here, it is b. If you have 2 here, it must be 2 before you can add this to that. And when you have a square root of b plus c square root of b, this is how you go about it. You add the whole numbers over here, or you add the rational numbers. All right, add the rational numbers, which is a over here, to c, and then square root of b. Do we get it? You only add the rational numbers and then you maintain one of the values in the square root, and that is it. That's how you add sets. If you want to find the difference too, you go through the same procedure. If you have a square root of b minus c square root of b, to find the difference, you subtract c from a minus c. Then you take one of the values in the square root. So it is a minus c, then square root of b. That is how you do it. That is how you add or subtract sets. Remember that when you have a set in this particular form, let's say a square root of b, and then you have another set c square root of d, you can't find the sum for these two sets because the b over here is not the same b over here. We have b here and d here. So it makes these two sets unlike terms. They are not alike. They do not look alike. So when that happens, you can't add this set to that set. So if you add it by writing this is wrong. There is a question mark about this. It is not done that way. It is wrong. You can only add or subtract sets that are alike. B in the square root b, then you can add this to this. B in the square root b, then you can add this to this. The b that we have here are representing values under the square root, and then the a's that we have over here are the rational numbers. I believe you have followed the concept. Let's box on, take examples that will help us understand the addition and subtraction of sets more. The first example that we are going to take will be 2 root 5 minus root 5. How do we solve 2 root 5 minus root 5? This is it. This is the concept that surrounds the difference or subtraction of sets. Once you have root 5 in here and then root 5, it means they are like terms, so you can find the difference. You have 2 here, we have 1 here, but the 1 that is here, it is not written. So in actual sense, this is how you go about it. You find the difference between 2 and the 1 that is here, but the 1 is not written. So it's like you are subtracting 1 from 2. Because they are alike, you can find the difference. So 2 root 5 minus root 5. So it is 2 minus 1 over here. That is the idea. 2 minus 1. 2 minus the 1 over here. But we don't write the 1. We don't write 1 root 5. No. Just as we don't write 1x, we don't write 1 root 5. But when you are finding the difference, you take 1 out of this. Subtract 1 from this. So it is 2 minus 1. Then take one of the root 5s. 2 minus 1 will give you 1, and that is equal to root 5. Remember, we don't write 1 root 5. We only write root 5. So if you have 2 root 5 minus root 5, it will give you root 5. That is the basic idea. That is the concept surrounding the addition and subtraction of sets. Let's take a second example. When you have root 5 plus root 5. Remember I said, when you have a question like this, we add the rational numbers that come before the values in the square root. So over here we have 1 root 5 plus 1 root 5. But we don't write 1 root 5 here. You don't have to write 1 root 5. The 1 is invisible. But at the back of your mind, you know there is 1 in front of the root 5 and there is 1 in front of the root 5 over here. So it is 1 plus 1, and that will give you 2. So root 5 plus root 5 gives you 2 root 5. I believe you are followed. Let's take a third example. Four root 2 plus 3 root 2. You can add this to this. Why? Because of the root 2 and the root 2 that you have here, make this set and this set like terms, so we can add. If you have root 2 here and then you have root 3, you can't add. because root 2 and root 3 are different sets. They are not like terms. They are unlike sets. Do we get it? So the only thing we do over here is to add the rational number to the rational number. So 4 plus 3 will give us 7. Then we take one of the root 2's. So 4 root 2 plus 3 root 2 will give us 7 root 2. Let's check it out. If you have 4 root 2 plus 3 root 2, 7 root 2. And that is what we have over here. 4 plus 3, 7, then root 2. Let's take a fourth example. Say 6 root 5 plus 7 root 5. Root 5. That is what you have to check. Check whether they are like sets, whether they are alike before you add or subtract. Root 5 is here, root 5 is here. So they are like sets. They are similar, so we can add. You add 6 to 7, and then you have 13. 6 plus 7 gives us 13. So when you add 6 root 5 to 7 root 5, you have 13 root 5. Confirming it on the calculator, when you have 6 root 5 plus 7 root 5, that is 13 root 5. That is what we have over here. 6 plus 7, 13. Then you take one of the root 5's. The fifth example. If you have 4 root 3 minus root 3, remember root 3 and then root 3. They are like terms, so we can find their difference. Do we get it? When you come to the rational numbers, we have 4 here, and then we have 1 over here. Though nothing is written over here, but I understand that there is 1 over there. So it is 4 minus 1. That will give you 3. So 4 minus 1 over here is 3. And then you add one of the root 3's. It's like you have 4x minus x to give you 3x. That is the basic idea. That is the basic concept surrounding addition and subtraction of sets. What you need to note are these. These are some of the things that you have to note when you are adding or subtracting sets. When you have root 3 plus or minus root 2, this can't give you any answer. In terms of sets, you can't add this to this. It is not possible. You only add or subtract like terms. So if you have root 3 and then root 2, don't say it is root 3 plus 2. So you have root 5. No, this is wrong. You can only add or subtract sets when the numbers in the square roots are the same. Over here you have root 3. 3 is different from 2. Hence, you can't add root 3 and then root 2. I believe you have followed. Let's move on. Let's take a look at some questions in detail. This is the question that we have. And how do we solve this? Remember, 50 and 32 are not like terms, so you can't just add. This is some of the detailed questions that I'm talking about. You have 50 over here and then 32 over here. So this is how we go about it. Simplify the first one and simplify the second example. When you are done, then you add them, provided you have the sets to be like terms. Do you remember how we simplify sets? Did you follow the previous lesson? Let's simplify this. From here, square root of 50. What perfect square multiplied by a prime number will give us 50? That is 25 multiplied by 2. So 50 will give us 25 times 2 gives us 50. Then plus what perfect square multiplied by a prime number will give us 32? That is 16 multiplied by 2. 16 is a perfect square, 25 is a perfect square. Note this. take the square root of 25 separately and the square root of 2 separately. Square root of 25 multiplied by square root of 2, then plus square root of 16 multiplied by square root of 2 separately. Square root of 25 gives us 5 multiplied by root 2 plus square root of 16 gives us 4 multiplied by root 2. 5 times root 2 gives us 5 root 2, and plus 4 times root 2 gives us 4 root 2. 5 root 2 plus 4 root 2. Now, you see that we have root 2 over here and the root 2 over here. Good. It tells us that these two sets are like terms. Alright? They are like sets. So once they are similar or they are alike, this is the very best stage for us to add because they have the same values within the square root. So we can add or subtract. But in this case, we are adding. So we add 5 to 4. Then we have 9. Add the rational numbers 5 and 4. We have 9. Then pick one of the root 2's and attach it to the 9. So when you have root of 50 plus root of 32, the final answer will give you 9 root 2. Let's check this from our calculator. Root 50 plus root 32. You see, 9 root 2. So that's what we have over here, 9 root 2. Let's continue solving some detailed examples, 1 or 2 detailed examples on addition and subtraction of sets. Let's take a look at a 7th example. So this is the example that we have. We have 3 square root of 500 minus 2 square root of 125. We are subtracting 2 root 125 from 3 root 500. So we take the first one, simplify it, take the second one, simplify it, then we subtract the second set from the first one. That is if and only if there are like terms. So with 3 root 500, let us search for a perfect square multiplied by a prime number to give us 500. So we write 3 root. When you have 100 multiplied by 5, it will give you 500. It will give us a product of 500. And 100 is a perfect square, 5 is a prime number. So we go in for 100 multiplied by 5. 100 multiplies 5, then you have 500. Then we have minus 2 with square root of 125. When you take 25, multiply it by 5, you have 125. 25 is a perfect square, 5 is a prime number. So let's box on and solve this. So over here, we take 3, you find the square root of 100, 3 square root of 100 separately, multiply by root 5. Then minus 2 square root of 25 multiplied by root 5. So 3 root 100 becomes 1 times root 5. Then minus 2 root 25 becomes 1, then times root 5. So 3 square root of 100 will give us 10. Square root of 100 is 10, and 10 will multiply the 3. So square root of 100 is 10 over here. The 10 is multiplying this 3 times root 5 minus 2. Square root of 25 will give us 5. The 5 will multiply the 2 here. Then times root 5. So 3 multiplies 10, we have 30. Multiplied by root 5. Minus 2 multiplies 5, we have 10. So it is 30 multiplied by root 5 minus 10. 2 times 5 gives us 10, then times root 5 times root 5. 30 multiplies root 5, then we have 30 root 5. 10 multiplies root 5, then we have 10 root 5. So root 5, root 5, they are like terms. We can find the difference. we can subtract this from that. So we have 30 minus 10, and that will give us 20. When you take 30 minus 10, you have 20. Then pick one of the root 5s. Therefore, the final answer is 20 root 5. So when you have 3 root 500 minus 2 root 125, the final answer will give us 20 root 5. Let's check it up here. When you have 3 root 500 minus 2 root 125, the answer is 20 root 5. So this tells us that our answer is correct. In our next lesson, we are going to take a look at some of the detailed questions on addition and subtraction of sets again, and then continue by looking at some of the rules that we have in sets. Thank you for learning from this particular channel. It's a goodbye for now.